So now today I am going to jumping into the Hadoop core components. Okay.
Right.
Now I think you are clear about NTFS file system and distributed file system and Hadoop distributed file system.
Yes.
Okay. Now we are going to discuss the main core components in Hadoop. Okay. Usually we have two core components in Hadoop. Okay. One is, you can say, some two layers. One is HDFS, another one is MapReduce. Okay, you can say something called, it is HDFS. Another one is MapReduce. Okay. HDFS is the actual one storing the data. Okay, the data is going to be stored in HDFS, in Hadoop distributed file system. Okay, in a cluster. Okay, that the data is going to be distributed in the systems. That means it is in a distributed cluster. Now we are calling it as a Hadoop distributed file system. And on top of that, we have a one layer, MapReduce layer, that is called in a processing layer. The data is going to be processed through the MapReduce. That means without MapReduce, we cannot process the data into Hadoop. Process in the sense, it is not storing. For the storing data, MapReduce is not needed. Okay, MapReduce is not needed. To process is nothing but whenever you want to fetch the data, okay, by applying some aggregate functions or by applying any operation, compute operation. You know what is meant by compute operation?
Any sort of manipulation of the data?
Yeah, that means you are going to do some manipulation on data. Okay, you are going to do some manipulation on the data. That means you need to apply some operation, any logic. Okay, either you may need the entire data or you may need some part of the data. Okay, suppose for example I have a 1 GB data. Okay, for example I have a 1 GB data in HDFS. Okay, now you don't want to fetch entire data. You need only some portion of the data in among 1 GB. Maybe you need some 100 MB data. So that means you need to apply any like some operation you need to apply on this. Yes, you need to apply some operation on this data. That means the data is going to be reduced and some operation is going to be performed and you are going to get the required data by applying some transformation. So if you are applying some transformation, how the transformation is applying on the data, okay, that is through the MapReduce. Through the MapReduce it is going to be happening. Okay, through the MapReduce it is going to be happening. And how it is going to be done is, in the MapReduce we have a two daemon services. In HDFS, what are the components? I think I already discussed yesterday. What are the components in HDFS?
Do you mean the blocks or the nodes?
Yes, like we have a name node, as I discussed yesterday. We have a name node, and again we have a data nodes here, distributed systems. These are all, even name node, data nodes, these are all distributed only. Everything, every system is connected with each other. Okay, but anyway, the name node is controlling all the data nodes, and again they are all distributed. Okay, they're all distributed system. That means they have applied some distributed software in all the systems. That is why they are distributed systems. Okay, this is called, even we have a secondary name node is there. Secondary name node is not a distributed node. It is, it is not part of into, it is not a part into Hadoop cluster. It is, again, it is different. That means the data is not going to be stored in any secondary name node. Only the logs and edit logs, file system image, it is going to be captured. It is different from the Hadoop system. Okay, only the name node and the secondary name node has a connection. Okay, the secondary name node don't have the connection with the other data nodes. Only the name node and secondary name node has a connection. Okay, this is what we yesterday we have discussed. Now in the map reduce you have a two daemon services. Okay, one is, okay, two daemon services are there. One is job tracker, another one is task tracker. Okay, one is job tracker, another one is task tracker. Okay, this is job tracker, another one is task tracker. Okay, so what is meant by daemon service? What is meant by daemon service?
I'm not sure.
Yeah, daemon service is nothing but the process which is running behind the system. Okay, the process which is running behind the system, that is called a daemon service. Okay, for example, go to your personal laptop. If you press Alt Control Delete, you will get on Task Manager. An option is there. If you go to the Task Manager, there you can see some processes and services are running. Am I correct?
Yes.
So, have you opened anything in your system regarding those processes and related thing? For example, you have opened some Word document. So, the Word document, it is going to be showing in your process or services. Yes, obviously, like you have opened. Sometimes, for example, if you open some Word document, it is not responding. Okay, so what you are going to do? You are going to open Alt Control Delete and go to the Task Manager, and you are going to end the process. Am I correct?
Yes.
So, like that, you have so many processes that are running behind the system. That means if you want to open any application on your system, that has to support. The services or the processes has to support to open your Word document or any other application in your system. Without the processes are not running, you cannot open any single application in your system. Application in the sense that may be any notepad or WordPad or whatever it may be, Excel sheet, whatever, any software that you are going to open. Okay, even if you open any web browser or whatever it may be. Okay, those are all called applications. Are you clear on that?
Yes.
Yeah. Now, so behind on your system, some processors are supporting to open applications. In the same way, here also, what is going to be happen is the job tracker and task tracker has to support or service, okay, or to process your data. These are the actual the services that are going to support your this thing. You can say HDFS is your your body, and if you take in a human, HDFS is our body, and the organs like all you can say some heart, okay, or some other things inside our our body, some organs. They are like map reduced. You can say heart is heart and the mind, okay, whatever it may be, you can think those you can treat it as a map reduced. What the process or whatever it is going to be happen through our mind, and the map reduce is hard. It is again a key point in your body. In the same way, in Hadoop, the map reduce is going to be taken care as a key point.
Okay.
You are getting me?
Yes.
Okay. Now I am going to explain you how it is going to be done. Okay. I am going to explain how it is going to be done.
All right.
Okay. Now, here the name node and job tracker we can call it as a master nodes. Okay. Just I am going to writing architecture, the Hadoop architecture. Now the clear Hadoop architecture I am talking about. Okay.
Okay.
Now here my name node will be there. Here my name node will be there. This is my name node. Okay. And here I think I told you the rack awareness concept. Okay, I didn't. Okay. Let me explain the rack awareness concept also. This is my control Z. See, usually we'll have a some data centers in every, okay, for every client or whatever you can consider. You know what client is nothing but any account, you can say some bank, some Citibank or Bank of America or Caterpillar or manufacturer related. Okay, you can take any different thing. Even Apple has also some data center. Yes, for example YouTube, you can take YouTube is an application. So YouTube has some data center. Facebook also has some data center. Am I correct?
Yes.
You know as what is data center is? It is a set of some computers that are physically located in some place that is called a data center. Are you clear on that?
Yes.
Okay. Now, so I am going to explain you the cluster including everything here. This is my data center 1. Okay. This is my another data center. Okay. Now in the data center you have a racks. In the data center you have a racks. The set of racks in the data center you have a some set of racks. Okay. This is called, I have a 2 racks, and here also I have a some 2 racks. This is another rack, and this is another rack. Okay. Now here I am going to put some data nodes in my rack. So where the data nodes are going to be kept, like where they are going to put the data nodes, in the racks they are going to place. Okay. In the racks they are going to place the data nodes. Now I have a 3 data nodes in my one rack. Okay. And again I have a another, I have a some other data nodes in my another rack. This we can call it as a multi-node cluster. Okay, multi-node cluster is nothing but if you have a more than 2 nodes, that is called a multi-node cluster. Yes,
Okay.
or 3 nodes or more than 2 nodes or more than 3 nodes, that is called a multi-node cluster. Now, so here I am going to assign one data node for one node for name node. Control that. Here I am going to assign this node for name node. Okay. We are going to assign you can say secondary node. Okay. I'm just giving secondary. Okay. We are going to assign this is for secondary node. Now the others are data nodes. Okay. The others are data nodes. This I am going to give some name as some data node 1. I am just giving dn1. Okay. I am going to give dn1. Okay. And again I am going to give dn2. Okay. I am going to give some dn3 for this. dn3. I am going to give dn4. dn5. dn6. dn7 and dn8. dn9. Okay. dn10. Let's give me. Yeah, give me a minute. Yeah, hello.
Hello.
Okay. So I have a data node 1, data node 2, data node 3, data node 4, data node 5, and up to data node 10 I have it. Okay. Now here, so obviously every data node has a link up with everything. Okay, everything. It has all the connection like this, like this. Okay, like this. It has a connection. Okay, so everything have a connection. Even it is also have a. They have some switches here. Okay, they have some switches here. Okay, it is a switch. Through the switch, it is going to be operating. The switch is going to be operating all the racks. here also, no, you can say some switches are there here. Okay, this is a switch. It is going to be operating all of them. Now here we have a some everything. Okay, like this it has the all the connections. It has a connection. Just a minute. Here, so I'm going to tell you the word. Okay, now for example, I have a some 128 MB file. Okay, 120 MB file. So my block size is 128 MB. Okay, my block size is also 128 MB. I have a 120 MB file. So it is going to be stored in data nodes. Okay, it is going to be stored in the data nodes in terms of some blocks. Okay, this is one block. For example, my data node has a some 3 blocks. Okay, for example, it has a number of blocks. I am just giving you a example. Okay, I am just giving an example. This is also one block. Okay, this is also a one block. Okay, so it also has some block. Some, for example, think that it has a some. Okay, like this, it is going to be done. It has a some 3 blocks. It has a 3 blocks. It also has a, so like this, data node 4 also have, data node 5 is also having like this. Okay, even data node 6 also have some 2 blocks, for example. Some are 3 blocks, you can say, consider. Okay, it has a some 3 blocks. Okay, it has some 3 blocks. Okay, now okay, so it is, my file name is some file 1. Okay, my file name is some file 1, file 1, or let us consider our okay, let me explain you this example, then I will teach that one. Okay, so here okay, so here 128 MB file is there, file 1. It is going to be stored, the data is going to be stored maybe in the data node. Okay, in the data node 1, maybe in the data node 3, maybe here. Okay, so as I discussed yesterday, Hadoop has a by default replication factor is 3. Hadoop has the replication factor is 3. Yes, it has a replication factor is 3. Now here
I'm sorry, what is a replication factor?
replication factor is nothing but it is a copy of data, copies of data. That means duplicate data. Hadoop by default it is going to be stored 3 times. The same copy of the same data is going to be stored 3 times in the
Okay.
Hadoop system. Why? Because I'm going to explain why it is going to be storing 3 times. So you know the data center concept and disaster recovery management, disaster recovery.
Yes.
What is disaster recovery? Obviously, it is in general.
No, it's redundancy to recover data. So whenever a hard drive failure or anything of the sort happens and a lot of data is lost, it can be recovered in some way, shape, or form.
Yeah. So that is why I have a two data centers. This is one DC. Okay. This is DC1 data center 1. This is my DC2. Okay. This is my okay. That is the DC1 and this is DC2. Okay. So now my file is stored in two data nodes in data center 1 it is stored in 2 racks, and in data center 2 it is stored in 1 rack. Now we can say, for example, in worst case, if one of my data center was crashed or something happened due to because of some floods, okay, here these two data centers are placed in different locations. That is why we are calling it as a data center. For example, this data center is on some New York, okay, the data center is in some other area, some Chicago or somewhere. Okay, so maybe in Chicago something happened, some floods or something happened. Okay, some heavy rain due to because of that some floods came, and the entire data center too got crashed. So can I get the data from the data center 1? Yes.
Which data center was in Chicago?
Data center 2 is crashed. It is
Okay, then
it
we
is
can recover from data center 1.
we can recover from the data center 1. So in the same case, if the data center 1 is crashed, so can I get the data from data center 2? Yes.
Yes.
Okay. Now again, come to data center 1. For example, I have a 2 racks. Yes, I have a 2 racks here. Now one rack is got crashed due to because of something. Okay,
Hmm.
some short circuit or some other happened, some hardware failure, hard disk inside that some RAM failure or hard disk or processors are got failed. So can I get the data from rack 1? Yes, this is my rack 1. I forgot to write it. This is my rack 1.
If rack 1 has a failure, then you can get it from either rack 2 or you can go to data center 2.
Yeah, we have two chances. Yes, two options.
Yes.
So that is how we can recover the data. Just give me 2 seconds. Just
Hmm.
or else 1 minute. I need to check something here. Okay. Now, so here what is going to be happen is I am the client. Okay. For example, I am the client. I'm submitting the job. I am submitting the job. Okay. I'm submitting. Okay. So I am going to submit a job. Here I am going to submit a job to fetch the data. Okay. To fetch the data from, okay, this data one. I don't want entire data. I have applied some logic. Okay. Suppose I have some paragraph, some like, Monday, Tuesday, Thursday, something called my file is something called some Tuesday, some Tuesday, Monday, Wednesday, okay, and again I have some Wednesday, okay, some Monday, some Thursday, again I have some Saturday, again some Sunday, again some Friday. Okay. Now this is my file. This is some 300 MB. Okay. Now the first line is in. Okay. Forget about all the colors. Concentrate on some coffee color. Okay. So concentrate on copy color. I am going to concentrate on only one copy of the data. So my first line is stored in this block. Okay, in this data node one of first block, and my second line is stored here. My third line is stored here. Now I want to find out how many times each word is repeated. Okay, here first of all find out how many different words are there. Tuesday one, Monday one, Wednesday one, and Thursday one, Sunday, Saturday, Friday. 1, 2, 3, 4, 5, 6 we have it as, I guess. We have almost 6. Okay, 6 words are there. We need to find out how many times each word is repeated. So I have written some logic and I have submitted a job. I have submitted a job. So initially the job is going to be submitted to the job tracker. Okay, the job is going to be submitted to the job tracker. So the job tracker is going to be sending a request to the name node. Why? Because the job tracker don't know where is the data. As I told you yesterday, what the name node contains?
The name node contains tables to the data, so it's like a primary node where it handles where all the locations of how the data is split up and where to access it if you want to
Yeah,
read some of
as
the
I
data.
said, yeah, the name node contains the entire information of data nodes and where the file is stored, in which data node the file is stored. Okay, everything, in which block the file is stored, everything is holded by the name node. Am I correct?
Yes.
So the job tracker is going to be contact to the name node. Name node is going to give the list of data nodes and the blocks where the data is stored. Okay, it is again going to send a reply back to the job tracker. Okay, with the list of data nodes and all the blocks information it is going to be providing. Now the job tracker is going to be assigning the particular task tracker, because on each data node we have installed task tracker. Yes. So the job tracker knows in which data node which task tracker is there. So it is going to be assigning the task to the task tracker to fetch the data from the data nodes by applying the reduce logic, whatever the logic, to find out the count. So it is going to be, okay, the task tracker is going to hit the block. So all the task trackers are going to hit all the blocks. Okay, all the blocks they are going to hit it, and so the data is coming, and all the in somewhere in intermediate stage they are going to merge the data. Okay, for all of them. Okay, so it is going to be fetching again from here to here. So here it is going to be merging, and the logic is going to be implemented, and they are providing the results to the job tracker. Okay, the job tracker is again, okay, it is going to give the result to us. It is going to be giving the result to us. That means again it is going to be storing in some HDFS only. Some path it is going to be storing. Okay, wherever we give, it is going to be stored in HDFS, either in, we don't know in which data node. We'll give some directory name, some folder name. It is going to be stored there. We need to go there and we need to check the result. Now you got it on high level.
Yes.
So we'll go ahead with no, from tomorrow.
Okay.
Okay. Okay. Okay. See you guys. I'll meet you tomorrow.